All right, so for type 2, first thing we have a function, fx equals 1 over the square root of x minus 2 over the integral from 0 to 5. So it says sketch the graph. And let's see here. So from 0 to 5, we have that. So 1, 2, 3, 4, and 5. So with this, let's see here. Oh, man, there's an issue. What's the first issue? Uh, yeah, what can you not have in the denominator? 0. So we know that x cannot be 2. What else can you not have inside of a radical? Negative number, which means x must be greater than or equal to 2. Since it can't be what? Equal to 2, my final domain issue is that x must be greater than 2. So I'm going to have a vertical asymptote here. Okay, no values to the left. So there is no value per 0 to 1, or 0 to 2 on the left side. Okay, then on the right side, we have an asymptote. So at 3, we would get 1. Okay. At 4, we get less than 1, and we get closer and closer to 0 here. So go. So why would the integral from 2 to 5, okay, of 1 over 2x be considered improper? Well, because at x equals 2, we have what type of discontinuity? There is infinite discontinuity. So solve for the integral just from t to 5 instead of from 2 to 5. So how do we solve for this integral? Because we do have a function inside a function, and anytime we have a function inside of a function, we're going to have to do some inverse chain rule. And what is our answer for inverse chain rule? U substitution. So not a hard one. U is equal to x plus 2. What's du? Just dx. Because derivative of x is 1, derivative of 2 is 0. So not so much an issue here. So we have integral from t from 5 to 1 over the square root of u du. Oh, yeah, it is x minus 2. All right. So now we can count that as u to the negative 1/2. And to do the integral of that, we add 1. Okay, so negative 1/2 plus 1 is just 1/2. And we divide by that sum. So dividing by 1/2 means I'm going to get 2 square root of u. All right, from the integral from t to 5. Now that's going to give me, this out of the way, don't need that. Plug x back into square root of x minus 2 from t to 5. So if I plug in 5, I get 2 square root of 3 minus plug in t, 2 square root of t minus 2. So if we want to find the limit as x approaches t from the right, okay, what's happening as x approaches t from the right? What am I getting? I'm getting infinity. All right. So the limit as x approaches 2 from the right of s of t, which is of my answer here, of 2 square root of 3 minus 2 square root of, well, in this case, it's 3t, not x. Sorry. T minus 2. Now, we don't really have to do much because we're just going to plug in 2. I have to look at the graph. We're going to plug in 2. What happens? It's 0. So we get 2 square root of 3. So, definition of type 2 improper integrals. So type 1 was when one of our bounds went to infinity, or both bounds went to infinity. Okay. Type 2 improper integral is when one of your bounds, either one of your bounds does not, the limit does not exist. Okay, sorry. One of the bounds has infinite discontinuity, or some type of discontinuity. Okay. Or there's a value c such that you have a type of discontinuity between your bounds. So if that's the case, then you do need to separate your integrals from a to c, then c to b. So if your upper limit has the discontinuity, then we're going to take the limit as t goes to b from the left, because it's the upper limit. It's going to be on the left of that value. If the lower limit has a discontinuity, it's going to be as t approaches that lower value to the right, because, again, it doesn't exist on the left within those bounds. And if it's in between, we do have to separate. And when you separate, you will then take the limit as c goes from, or t goes to c from the right, and the limit as t goes to c from the left. All right. So, where is my discontinuity on this one? Oh, natural log of 1 is what? 0. But what's the natural log of 0? Doesn't exist. So, here is my discontinuity. So we're going to take the limit as t approaches 0 from the right, okay, of the integral of t to 1 of the natural log of x dx. Now, do you remember doing the integral of natural log of x? That's the other way around. It would, if it was 1 over x, we would get natural log. But what derivative gives us natural log? There isn't one. So, what do we do in this situation? We did integration by parts. We actually did this one already. And this was the weird one because you have to. There's really no way to get this without just knowing this is what you have to do. Okay. So when we say integration by parts, usually we have two functions in there, right? Well, if I don't have a function, that means I have an understood 1. So times 1. So if u is equal to the natural log of x, v, or v prime, is equal to 1 dx. What is the antiderivative of 1? X. What's the derivative of natural log? 1 over x dx. So this is going to separate into the limit as t goes to 0 from the right. It was what, u times v, so the natural log of x times x minus the integral from t to 1 of u prime v. So 1 over x times x dx, which is just 1. Yes.
So if the bound that was causing the discontinuity was the upper bound, we replace that so you're gonna have it equal in the negative direction.
If it's, yeah, is that brown? Yeah. Now, there's one thing I'm missing on here. We actually have not done integration by parts with definite integration, have we? No, I haven't. So I'm missing something here, which is this part right here. T to 1. Right? So I'm not again. I did not give anybody enough room to. Oh no, there's some room here. So that's good for me anyway. How about you guys? So this gives me the limit as t approaches 0 from the right. Here, if I plug in 1, I get 0, because natural log of 1 is 0, right? All right. Minus t natural log of t. All right. All right. Minus here, if we, it's just the, what's the antiderivative of 1? It's x. So I have x from t to 1. So minus 1 minus t. Right? From, no, that's it. Let's see. So we end up with the limit as t goes from 0 to the right of negative 1 minus t natural log of t plus t. Now, what happens when I plug in 0? That's 0, that's 0, so we just get negative 1. That was fun. Any questions on the first part? The second. So the arrow from 0 to 3 of 1 over x minus 1. Now the issue here is inside my bounds, I have an infinite discontinuity which exists at 1. So we need to separate this as the integral from 0 to 1 of 1 over x minus 1 dx plus the integral from 1 to 3 of 1 over x minus 1 dx. Right? So we're going to take the limit, we'll do this, as t approaches 1 from the what? Since it's the upper bound here, it's on the left, right? Yeah, I wrote this backwards up here. Should be left to right. Yeah. So from the left of the integral of t, 0 to t, right? Of 1 over x minus 1 dx, plus the limit as t approaches 1 from the right, integral of t to 3, 1 over x minus 1 dx. Now, what is the antiderivative of 1 over x plus 1? Yeah, natural log of x plus 1. So, limit as t approaches 1 from the left of the natural log of x plus 1 from 0 to t. Limit as t approaches. It is minus 1 here, I think. So you approaches 1 from the right of natural log of x minus 1 from t to 3. All right. Now, the issue here is what? If I plug in 0, what do I get? A negative 1. What's the problem with that? Yeah, you can't do that. Okay. Yeah, right here, this gives you what limit as t approaches 1 from the left of natural log of t minus 1 minus natural log of negative 1. Even this, just this part right here, that is negative infinity. Yeah, natural log of, yeah, that right there. Because it approaches infinity, what is my answer? Does not exist. Divergent. And again, it's enough to show one part. You don't have to go through the rest. Right. So, questions? All right. There will be some homework on Delta Math. Yeah. I only did type 1. There's not a lot. So,